Example 5. Francisco needs to know the height of a tree. From a given point on the ground, he finds that the angle of elevation to the top of the tree is 36.7 degrees. He then moves back 50 feet. From the second point, the angle of elevation to the top of the tree is 22.2 degrees. Find the height of the tree to the nearest foot. All right, we are going to have to draw this out. Okay, so basically, let's go ahead and put the ground here. Okay, so here's the ground, and then we have this tree somewhere. Okay, so we'll just say that the tree is right here. Okay, so here's the trunk of the tree. Okay, and here's the top of the tree. Okay, so here's a tree. And Francisco's trying to come up with the height of this tree. Okay, so we've got to draw Francisco. Okay, so here's Francisco. Okay, and what we're told from a given point on the ground, let's call this point A. Okay, he finds that the angle of elevation to the top of the tree is 36.7 degrees. Okay, so I'm going to go ahead and draw, okay, from the point on the ground here to the top of the tree. Okay, this angle of elevation is going to be 36.7 degrees. Okay, notice from doing this that I have created a right triangle. If I draw from the top of the tree to the base of the trunk here, this is forming a right angle. Okay, and we know an angle that is right here. We know this angle is 36.7 degrees. Okay, all right, then if you continue reading, you're told that Francisco moves back. Okay, so he's going to move to a second point B. Okay, and he moves back 50 feet from where he was. So we're told that, well, based on that information, we know that the distance from this new point to the original point A, this distance has to be 50 feet. Okay, so this is going to be 50 feet. Okay, and then from this new vantage point, so we have Francisco right here. Okay, from this new vantage point, the angle of elevation is now a smaller angle, and you can see that by just drawing here. Okay, the angle of elevation is now 22.2 degrees. Okay, and again, if you use this same length from the top of the tree to the base of the tree trunk, we're getting a second right triangle. Okay, so you have a blue right triangle and then you have a red right triangle. Okay, there are two triangles. Okay, we're trying to find the height of the tree. Okay, so the goal here is this yellow value. Okay, I'm going to go ahead and give this a name to my variable here. Let's go ahead and call this H for height. Okay, we're trying to find the height of the tree. All right, so let's come up with a plan of attack here. Okay, we need the height of the tree, which is this black value that I have labeled H. Okay, we seem to be missing, we're missing a key piece of information here, and that is the distance from point A to the base of the tree. Okay, so that's kind of another unknown. It's not the one we're looking for, but that is unknown. I'm going to call that distance X. So again, that's the distance from point A to the base of the tree. Okay, we kind of need that value here because then if you look at the red right triangle, you'll have the angle and then you'll have this distance X, and that will allow you to calculate the height. Okay, so let's see if we can figure out this this X value. Let's focus on the red triangle here. If we look at this red triangle, okay, this height is the opposite side, and then across from the right angle, that's the hypotenuse, meaning this X value is the adjacent side. Okay, so what I'm going to do, I'm going to use tangent here for opposite over adjacent. I know that the tangent of 36.7 degrees is equal to the opposite side, which is H, over the adjacent side, which is X. We don't know that. Okay, I can do the same thing for the larger blue right triangle. Okay, I know if I draw straight across from this 22.2 degrees, the height is also the opposite side of the blue triangle. Okay, if we go across from the right angle, this longer blue side is the hypotenuse. Okay, and for the blue triangle, the distance from B to the base of the tree here, this entire side is the adjacent side for the blue triangle. Okay, so the tangent of 22.2 degrees is equal to the opposite side, which is the height, over the adjacent side. The adjacent side for this blue triangle is made up of the distance from B to A, which is 50 feet, plus the distance from A to the base of the tree, which is X. Okay, so these are two different trig ratios. Okay, and we have two variables involved, H and X. Okay, but look at what happens here. Okay, we can take each of these guys, each of these ratios, and solve for H. Okay, so in this first ratio, if we multiply both sides by X, this is going to tell us that H is equal to X times the tangent of 36.7 degrees. If we do the same thing for this second ratio, if we multiply the top and the bottom by the denominator 50 plus X, this is going to tell us that H is equal to the entire quantity 50 plus X, so use parentheses, times the tangent of 22.2 degrees. Okay, why am I doing this? Because now I have two different calculations for H. Both the quantity X times the tangent of 36.7 degrees and the quantity 50 plus X all times the tangent of 22.2 degrees, both of those quantities have to be equal to H. Since they're both H, I'm going to set them equal to each other. Okay, so I know since they both have to be H, this means X times the tangent of 36.7 degrees has to equal the quantity 50 plus X times the tangent of 22.2 degrees. Okay, this eliminates one of the variables. Now I'm left with a statement that just contains an X. I'm going to be able to solve for X. Once I have X, I will be able to get H from that. All right, so let's solve for X here. X, I'm going to just follow my instinct and distribute on the right side here. So I'm going to send tangent of 22.2 through the parentheses. So we're going to get X times the tangent of 36.7 degrees is equal to 50 times the tangent of 22.2 degrees plus X times the tangent of 22.2 degrees. Okay, so this term contains an X, this term contains an X, this other term is just a number. Okay, I want to put everything with an X on one side, so I'm going to move this term over. So I'm going to subtract it from both sides to undo the addition. All right, so let's see what this is going to give us. Okay, so let's see, I'm going to write this all out. We're going to be left with X times the tangent of 36.7 degrees minus X times the tangent of 22.2 degrees is equal to 50 times the tangent of 22.2 degrees. Okay, so on the left, both terms contain an X. So what I can do is factor it out. If I factor out an X on the left, in the parentheses, I'm going to have tangent of 36.7 degrees minus tangent of 22.2 degrees. Okay, I'm not going to make any changes to the right side. Okay, now this quantity that X is being multiplied by, tangent of 36.7 degrees minus tangent of 22.2 degrees, that is just a number. If you pop it into your calculator, that's what X is being multiplied by. So to solve for X, we just need to divide off this number. Okay, so X is going to be 50 times the tangent of 22.2 degrees over the tangent of 36.7 degrees minus the tangent of 22.2 degrees. Okay, so that's going to give us our x value. Okay, I'm going to go to the calculator. I'm going to pop in 50 times the tangent of 22.2 degrees. Okay, make sure you're in degree mode. When I divide, make sure the entire denominator is in parentheses. Okay, so we're going to have, open your parentheses. This is the tangent of 36.7 degrees minus the tangent of 22.2 degrees. Close the parentheses on the tangent, close the parentheses on the denominator. Okay, this is the value of x. Okay, so I'm going to write out the full decimal expansion. So 60.496. You need the full decimal expansion for accuracy. 75201. Okay, so now that we know the x value, we can get the h value. Okay, if you go back up, look at my two ratios that I've already formed. Okay, I have a choice between the red ratio and the blue ratio. I'm going to stick with the red ratio because it just looks easier. Okay, we've even already solved it for height. We know to get the height of the tree, we just need to do x times the tangent of 36.7 degrees. Okay, so I'm going to come over here. Okay, and I'm going to write this down. To get the height of the triangle, we know that x, we have to do, the height is x times the tangent of 36.7 degrees. Okay, we just computed x. It's this green number at the very bottom. Okay, we need to, like I said, maintain all the digits for accuracy. So I'm going to write this x value down. Okay, multiply it by the tangent of 36.7 degrees, and that is going to give us the height of the tree. Okay, so we need to take this value, multiply it by the tangent of 36.7 degrees. Okay, here it is. Okay, so I'll write the full decimal expansion and then we'll round. All right, so this is the height. Height is measured in feet here, as all the lengths are. Okay, we are told to round to the nearest foot. Okay, so if we look at this, after the decimal there is a 0, so we just need to keep 45 as it is. We do not need to round it up. So the height of the tree is going to be 45 feet, and we are done with this problem.